Hey, welcome to the Explainer. Today we're going to talk about something super fundamental, how to find the hidden stories in your data just by looking at two things at once. It's a skill every data person needs, and we're going to break it down.
So let's kick things off with a simple question, the kind of thing you totally find in a medical data set. Think about it. As people get older, what do you think happens to their maximum heart rate? Answering this is really the key to unlocking a super powerful data viz technique. And that technique, it's called Bivariate Visualization. Sounds kind of fancy, right? But it's really the heart of what we call exploratory data analysis, or EDA for short. This is how we stop looking at just single data points and start to see the bigger picture, spotting correlations, trends, and all the interesting outliers.
All right, here's our game plan for today. We're going to start with that simple heart rate question, and then step by step, we'll build out a complete framework that'll let you handle pretty much any pair of variables you come across.
Okay, let's jump right in. Now, here is the absolute key to all of this, choosing the right chart, the right visual. It all starts with one thing, understanding what type of data you're actually working with. And you know what? It really just boils down to these three combinations. Are you comparing two sets of numbers, things you can measure, like age or height, or maybe a category and a number? Or are you comparing two categories, things that fall into specific groups, like smoker versus non-smoker? Seriously, this simple framework is the secret sauce to making your data make sense visually.
So let's tackle that first pairing. What happens when you've got two numerical variables, what we call continuous data? We're talking about things like age and blood pressure, or maybe height and weight.
First up, we've got the scatter plot. This thing is the absolute workhorse for seeing if two numbers have a relationship, or what we call a correlation, with each other. And check this out. It perfectly answers that question we started with. Each one of those dots, that's a person. And you can just see it, right? As you move from left to right as age goes up, the dots for heart rate just drift downwards. That, my friends, is a classic negative correlation.
Okay, so let's build on that. What if we tweak the idea a little bit? What if one of your numbers is actually time? Well, in that specific case, the line plot becomes your absolute best friend. And wow, this chart is just a brilliant example of why line plots are so powerful. You're not just looking at a bunch of points here, you're watching a story unfold over 2 whole decades. You can immediately see that dramatic drop in one country versus the much more stable trend in the other.
So at the end of the day, it's all about picking the right tool for the job, right? Scatter plots give you a snapshot of a relationship. Line plots, on the other hand, are for telling a story over time. But hang on, what if you have way more than two variables? What if you want to see how they all play together? Well, a correlation heat map gives you this incredible, at-a-glance summary of everything at once.
Okay, let me walk you through this one because it's super cool. Each little square shows the relationship between two variables. Basically, bright red is a strong positive relationship, and dark blue is a strong negative one. You can literally scan your entire dataset for important insights in just a few seconds by looking for the brightest colors.
All right, let's shift gears and look at our next pairing. What do you do when you want to compare groups or categories, say patients with a condition versus those without, against some kind of number, like their cholesterol level?
For a situation like this, charts like box plots and violin plots are your absolute go-to tools. They give you this amazing summary of a number across different groups, showing you things like the average, the spread of the data, and where most values are clustered, all in one neat and tidy visual.
And for the last piece of our puzzle, let's see how to compare two categorical variables. This is when you're comparing two groups, like did a treatment work or not, across different stages of a disease.
This is where a stacked bar chart really shines. It lets you see not just the total for one group, but how another group is broken down inside of it.
And this is a perfect example. See those bars? They show 3 different stress test results. But look how they're stacked, with red for heart disease and blue for no heart disease. You can immediately see the story. The slice of red, the people with heart disease, is way bigger in the groups with reversible or fixed defects.
Okay, let's pull all of this together. I want to give you a simple little cheat sheet that you can use literally any time you're starting to look at a new data set.
And here it is, the whole framework all in one place. Just figure out your data relationship on the left, and boom, you've got your chart on the right. This is your starting line for any kind of bivariate analysis.
So if you walk away with anything today, let it be this. Always start by knowing your data types. Are they continuous numbers, or are they distinct categories? Once you know that, you can pick the right chart, and you're going to unlock the story that your data has been dying to tell you. And this is why it all matters so much. This isn't just about making cool-looking charts. It's about turning a bunch of raw, messy data into clear, actionable insights that can help people make much better decisions.
So now it's your turn to go exploring. What hidden relationships are just waiting to be discovered in your data? Thanks so much for watching.